Hi Geometry, it's Ms. Strauss back with the second half of 6.5 today. Today we are going to be talking about rectangles and squares and how they differ from other parallelograms. Yesterday we did rhombuses. So first we're going to warm up with some review of our rhombus material from yesterday. We have a quadrilateral ABCD and we're told it's a rhombus. We want to find the measure of DAB. So go ahead, pause the video, work this out, and then I will go through it with you. All right, so hopefully you got something that looks like this. Since we are told that ABCD is a rhombus, we can conclude a few things about that. First of all, we know that all four sides are congruent. We also know that we have our diagonals here, AC and BD. These are perpendicular bisectors of each other. So we know that right here, we've got a right angle. And then we know that these diagonals also bisect the angles across from each other. So if we see angle D and B at those corners, those are cut directly in half, and then same with A and C. We know that the angle DBA is 42 degrees. So if we take this as a triangle, we have a right triangle, so we've got 90 and 42. So we want to find out what this third angle is. So 180 is equal to 42 plus 90 plus the measure of CAB, so that's that third angle. Working through that math, we get 48. We're actually looking for the whole entire corner A though. And since AC is the bisector of angle A, we just multiply that by 2 and we get 96 degrees is equal to the measure of DAB. Now we're going to be moving into rectangles. We have another theorem. We had 16 and 17 yesterday. Today we have theorem 6.18. We are told if a parallelogram is a rectangle, then its diagonals are congruent. So remember, if we have a rectangle here, we have 4 right angles. And then we have the opposite sides are congruent and parallel. So if we call this A, B, C, D, and we create our diagonals right there. So if we have this, then we know that AC is congruent to BD. So the length of those diagonals is the same. So let's see what this looks like if we put this into practice a little bit. A carpenter needs to check the gate his apprentice built to be sure it is a rectangle. The diagonals are 52 and 53 inches. Is the gate rectangular? Explain. No, it is not. We are just told in theorem 6.18 that if we have a rectangle, the diagonals are congruent. Obviously, 52 is not equal to 53, so this contradicts 6.18. So obviously his apprentice is not ready to be building gates yet. Example 4. Let's go through this one. A volunteer group is planting a butterfly garden in a portion of a rectangular park. We want to find the perimeter of the butterfly garden. So we want to find the perimeter of this triangle right here. Since we know we have a rectangle, we know that this right here is 100, and then we know that this is 160. So we know one side of the garden, we just need to find the other sides of the garden. So since this isn't a rhombus, we don't have a right angle right here. We can't use the Pythagorean theorem. However, since we have a right angle right here, we can use that, change my color here to emphasize it a little bit, with this side and this side to find the length of Km. So using the Pythagorean theorem, one of the best theorems in all of math, we have, if we call this, Km squared is equal to 100 squared plus 160 squared. Km squared is equal to 10,000 plus 25,600. Km squared is equal to 35,600. So now we want to take the square root of both sides. So we're going to say that Km is approximately equal to, it's 188.68. I'm going to say 189. So that means this whole length here is 189 feet. Remember that since we have a parallelogram, our diagonals bisect each other. So that means this is the same length as this. So Kn is equal to 189 divided by 2, which is going to give us 94.5. Since our diagonals are congruent, that means that Jn is also equal to NL, and they're equal to these two chunks that we just found because JL is equal to KM. So that tells us that NL is also equal to 94.5. So the whole perimeter is going to be equal to 160 plus 94.5 plus 94.5, which is going to be equal to 349 feet. So now we know some stuff about rectangles, we know some stuff about rhombuses. Let's talk about squares. I want you guys to give this one a whirl on your own before I walk you through it. So go ahead, pause the video, give this one a try, and press play when you are ready. All right, so we have a square ABCD, CD, diagonals AC and BD. What is the measure of ABD? I drew this really poorly, so I'm going to do that again. Pen. We're looking for this one, and this is the angle that we're looking for. So let's talk about what a square is. So a square, remember, has 4 congruent sides. It's a parallelogram that has 4 congruent sides, kind of like a rhombus, and 4 right angles. Kind of like a rectangle. So, since it is a rhombus and a rectangle, all of the properties that we just learned apply. So let's draw in, we've got here, 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 right angles. All these are the same. Specifically, one that we care about right now is that rhombuses, the diagonals, bisect opposite angles. We know since the square is a rectangle, we have 4 right angles. So this is 90 degrees. So the measure of ABC equals 90, which tells us then that the measure of ABD is equal to 90 divided by 2, which is going to give us 45 degrees. So the last slide here is just a summary out of everything that we have learned, talking about properties of rectangles, rhombuses, and squares. I would make sure that you have this information copied down into your notes, and then go ahead and work on 6.5b Pearson.